Alright, welcome to the first class on your journey to data science. In this class, we will start with the absolute basics of data. It's important to identify what type of data you're looking at so you can wrangle it, clean it, munge it, and manipulate your data into a fitting model using Python. Also, at the end of this video, I will tell you what you are going to learn in the future videos and give you a path to follow. So if you would like to review these concepts in advance, I would encourage you to do so. I'm going to try to make these series of videos as comprehensive as possible, but please note you should also be using other resources out there. I'll give you a bunch of resources, but it's always good to get a different perspective on how other people think about data science. I'm not going to talk about what data science is or what it consists of. If you're watching this video, you probably already know. There are plenty of videos out there regarding this from a whole bunch of different perspectives. So let's get started on the types of data and the common types of data in Python, which should be a review. Having a fundamental understanding of data types for statistics and data science is important because you have to know what kind of statistical measurements can be done for each data type. You should know which visualization to use when creating graphs and charts too. So knowing the type of data you're dealing with allows you to group the data, perform measurements, and it can give an indication on how to proceed when you're creating models. The first type of data we'll talk about is categorical data. Categorical data is data that has non-numerical characteristics. This data can consist of gender, the language spoken, maybe educational background. This data is essentially information that can be classified into a group. Now there's an exception to note here. Categorical data can use numerical values, but these numerical values have no mathematical meaning. The numbers only enable you to group them into a category. For example, if you have a variable in your data that identifies gender, we can use 1 for male and 0 for female. Maybe you have answers to a question as a variable in the data that you're using. We can have 0 for no, 1 for maybe, and 2 for yes. In Python, the data type used for categorical variables is a string. And this can be any word, maybe it's letters or numbers, within a set of parentheses. You should know that when these numerical values are of the type string in Python, you cannot add, subtract, or do any kind of calculations on these numbers. So if we look at the examples here, we can see that each one of these elements within each one of these lists are, missed the parentheses there, but most of them are enclosed in a set of parentheses, indicating that these are strings in Python. So categorical variables can be broken down into two subsets, nominal and ordinal. The term nominal is officially defined in Webster's dictionary of or pertaining to a name or names having to do with the literal meaning of a word. So you can think of nominal as the meaning says, a name. Nominal data can be color, gender, male or female, or any other label you can think of for a variable. Next we have ordinal data. It's sort of a combination of categorical and numerical data. We should think of order when we hear ordinal data. So for ordinal data, we have a certain order to these variables. We can have education background, where the order of the variables starts with elementary, then middle, high school, college, and so on. Ordinal variables are usually used to measure features for something like customer satisfaction. We could start the scale at dissatisfied, maybe even indicating dissatisfied as 0, then 1 for neutral and 2 for satisfied. So for categorical data, we have it made up of two subsets, nominal, indicating a name, or ordinal, indicating a specific order within our data. Next, we have numerical data. Numerical data, you guessed it, deals with numbers. This can also be broken down into two subsets, continuous and discrete. Continuous variables, or continuous data, represents some sort of measurement. For example, weight, height, and length. These are all things that can be measured. Continuous data cannot be counted, but continuous data can be measured. So this can be any sort of data point within an interval. So it can take on any value within an infinite interval. So if we look at the difference here between discrete and continuous, we can see that continuous can be any point along this line here. So here we can have maybe 6.56. Here we can have 8.25. Whereas discrete, we have a finite or a countable number of possible outcomes. So here we can only have 2, 4, and so on. So with age measured as a continuous variable, we can say that 37.537 years old would be an example of that. There is some debate in treating a variable as an ordinal or continuous variable, but consider this when deciding between ordinal or continuous. As the number of categories increases, the more a variable starts to look and behave like a continuous variable. If there are a few categories, you can treat these as ordinal. So let's look at this example. If we're considering the years of experience within a data set, if we choose to use buckets to group our data, we could say that this was an ordinal type of data. These buckets are 0 to 5, 6 to 10. They're buckets because we're fitting maybe a load of, let's say a load of values into a bucket. Now using buckets, we would only be using 4 categories. Now if we used continuous variables like 1.54 and 2.45, you can have sort of an infinite amount of categories here. And therefore you should classify this then as a continuous data. You can search for more examples online or ask some questions in the comment section if you're still unsure. Okay, the last type of data we'll talk about is discrete numerical data types. Discrete data types are numerical values that are distinct and separate, so they are unconnected values. With discrete values, you can only take on certain values, and these values have to be counted. So here lies the biggest difference between continuous and discrete. Discrete values are counted, and continuous values are measured. Discrete values can be, let's say, the sum of 2 dice, a population, or the number of puppies in a litter. So usually, discrete values are distinct values of whole numbers or integers, and continuous values can be fractions or decimals that exist on any point of an interval. So just to review data types, we should remember that int or int stands for integer, which are whole numbers. Then we have floats, which are decimal numbers. Strings, that are words, letters, or numbers in parentheses. And if you're using Python, you can call type. So when I say call, you're using the function. So here we're calling print, and then we're calling type. And what that is going to do is it's going to return the type of that variable. For instance, in string 1, we have a string, good morning. We call print, and we call type for that variable, string 1. And then it outputs class string, letting you know what type of variable this is. Here we have integer, which is a whole number, no decimal points. Call print and type, and we get back int. And here we have a float, a decimal number, and we call print and type to return to us float, indicating that, yes, it is a float variable. So that wraps up data types. We will be using these terms in future videos, and don't forget, it is important to understand what kind of data type you're dealing with, because we want to know how to visualize them and what sort of statistical measurements that we can conduct on them. All right, so the 2 data types again: categorical, dealing with a category, broken into 2 subsets: nominal for the name, and ordinal, meaning order. And then we have numerical data, dealing with numbers. Then we have continuous, and these are measured values that can be any point on a given interval. And then we have discrete, which are counted variables that can be distinct or specific points on that interval. All right, so the next video coming up will be for pandas. Then we'll do a tutorial on NumPy. Then Matplotlib, generate some cool visualizations, and then on to statistics. All right, I hope you guys took something away from this, and see you on the next video. Have a good day.